Good morning, class. Today we're going to start a section called electromagnetic induction. It's a bit different from what we were talking about, which was electromagnetism. You know that when we have a current carrying conductor like this, and as the current is flowing, there will be a magnetic field surrounding it, which we spoke about the right-hand wire rule. But today it's the opposite. Today we're going to talk about a magnet going to induce an EMF through a conductor. Now, if you look at the setup that I have here, you can see that there is no power source. There's no battery. There's nothing switched onto the plugs, nothing. All I have here is, what is this device called, class? Yes, it's a solenoid. We spoke about the solenoid rule, where it is many turns of wire, cylindrical like this, where we have a solenoid. Now, all I have here is a solenoid. It's connected with conducting wires to a microammeter, and the reason why we're going to use a microammeter is we are going to induce a very small EMF in current. Okay, so as I move, if you look here, as I move my magnet, I am actually going to induce current here. And if you can see that as I move the magnet, you can see that the line is moving in opposite directions. So when the current is going like this, what kind of current am I inducing? Yes, very clever, John. It is AC current, alternating, moving in different direction. Okay, so versus if I had to use a battery, we would have a direct current moving in one direction. Okay, so if I look at my my magnet, we know we have a north pole and a south pole. So if I look here, we know that a magnet has magnetic field lines around it. Even though you can't see any field lines like this around this magnet, they do exist. Remember that it is a non-contact force. And if I had to sprinkle iron filings, which you saw in grade 10, which you saw earlier on as well, that the iron filings, being ferromagnetic, align itself in the magnetic field. And so we know, even like this pencil, if I drop it like this, it fell. It fell because of gravity pulling it downwards. Okay, it's a non-contact force. And so we have a magnet having a non-contact force. What's the other non-contact or the other field force? Yes, the electric field. Okay, and we did the section on electrostatics. So coming back here, the magnet has a magnetic field line surrounding it, moving from north to south. Now, as these magnetic field lines move through the area of the coil, an EMF is going to be induced. And what we actually have, sorry, is Faraday's law that we are going to talk about. Pause.